This molecule you see over here is called a phosphate ion. A phosphate ion has one central atom surrounded by 4 peripheral atoms, making it an AX4 bond with no non-bonding electron pairs. To prove this, we can draw a Lewis diagram. In the Lewis diagram, we would have the phosphorus in the center with single bonds connecting to 4 oxygens. On the outside of the oxygens, we add the octet, like that. Now though, so we can X out some of the positive ones and negative ones to get zeros, we will take away one of these octets. First though, we have to put it in brackets because it is an ion, and add the charge in the top right corner. So we take this octet away here and add it into a double bond. We can cancel this out. Now though, we want to find the formal charge of this to prove that this number up here is correct. To find the formal charge of phosphate, we do Fc for the phosphate, and then we put 5 minus 5 minus 0 equals 0. I will explain this later. First, to do the oxygen, we will do Fc for oxygen, for one of the oxygens, one of these oxygens, not this one. We will do 6 minus 1 minus 6 equals negative 1. Then to find this oxygen, we will do Fc of O2. We will do 6 minus 2 minus 4 equals 0. Then, to explain this, we take 5 valence electrons brought in minus 5 bonds minus 0 non-bonding electrons for phosphorus, which will make this formal charge 0. Then, we have 6 valence electrons brought in from each oxygen, 1 bond for each, and 6 non-bonding electrons for each oxygen, which equals negative 1, formal charge. Then remember to multiply by 3, which would equal negative 3, because we have 3 of these, 1, 2, and 3. Then lastly, we need to do the formal charge for the bottom oxygen, which is this one. To do this, we take the 6 valence electrons brought in minus 2, because of the 2 bonds here, minus 4 non-bonding electrons, which would equal the formal charge. Then if we sum those all up, so 0 minus 3 minus 0, we get a charge of negative 3, which would correspond to this negative 3. This is a covalent bond because the phosphorus bonds with the oxygen. All of these bonds are covalent. This is a tetrahedral shape and has bond angles of 109.5. So every single one of these bonds would be equal to 109.5, and so on. Each one equals 109.5. Because they all are oxygen, they have all the same atom, and all dipole moments will cancel out, which will leave this ion as a non-polar element, because the oxygens are all the same. They're all the same types of oxygen, because even this one in the beginning was the same. So all of these are the same, which makes them non-polar.